All right, our last section on money. We've been over through every formula except for one, so we've got our very last formula. This one's still going to be kind of talking about that annuities, but instead of continuing to deposit and growing our annuities like we did in section 5.4, now we're going to be doing the opposite. We're going to start with a lump sum and we're going to get paid out so much each month. And this really does happen. So I've got some examples here. These are kind of the fun examples. Maybe you win the lottery. If you win the lottery, you're usually given two choices. You can choose to take a lump sum. That lump sum is smaller than the actual winnings. Or if you want the whole thing that you won, then you can put it in one of these annuities and it will pay you out so much per month until you've used up your entire lump sum. And that's kind of set how long it lasts. And there's some gambles. If you're older and you pass away, you might not get your full amount out of the annuity. So there's definitely some choices to be made there. Or sometimes if you have a court settlement and it's a really big amount, they won't give you all of it at once. Instead, that will be put in an account and you'll be paid out so much each month or each year. You can have trust funds in the same way, or retirement accounts. When you go to retire, you don't want to pull all of it out at once. You want to get so much sent to your account each month, each quarter, each year, something like that. So now we're going to be starting with our big amount. So we're going to start with our present value. If you think back to what we did in 5.3, those accounts, we're going all the way back here, oops, 5.3, here we go. Those accounts started at zero amount, and they kept getting made. So as here he goes, we start at zero and kept getting larger. We're doing the opposite now. We're starting with a big amount and we're going to keep withdrawing that money until we get down to zero, until we've taken it all out and the balance is zero. And this present value is the amount of the money that's deposited today so that you can pay those out. So if we've got a court settlement and we need to pay out so much, you know, $200 every month for 10 years, we know how much we have to put into that account right now to make that happen. So that's this present value of the annuity here. On this formula, all the letters are the same. Just be careful, that is a negative on the end. So we are going to be using a negative here. All right, so let's look at an example. We want to find the present value, so we're going to look for P. We're going to deposit 890, so that's my capital R. T 16 years. My interest rate is 6%, and we're going to compound annually. So I'm going to plug that in to my formula. Be careful. I'm going to say that's -1 times 16. Be careful, there is a negative up there. We haven't used that. So something new you always want to watch out for. Just like with the last formula, you can type it in all at once, but I would suggest splitting it into the numerator and then the denominator. Now I've already typed mine in on my calculator so I can just look at it, so you don't have to waste time on the video with me typing it in, but you definitely need to hit pause and make sure you can type these in and get the same answer. And just like before, we're going to round to 2 decimal places because it's money. All right, we've got 2 more of these, so let's go ahead and flip over and look at the next page. Example 2 here. We've seen this in every one of the sections. We've got this formula we have to be able to solve for both sides. So here's the other side of it. We want to find the payment amount. So we're going to be looking for R so that we, for this present value of $120,000. So I've got $120,000, I'll write them out first, is going to be equal to P, my interest rate. I'm compounding semi-annual, or depositing that semi-annually there and compounding semi-annually, and that's for 20 years. So this is going to be the one where I have to do a little bit of algebra on it. Be careful, I know I've said it a couple times, but I'm always wary of that negative sign. Doing the right hand side. Going to type in the numerator. Going to type in the denominator. Make sure you're getting these in the calculator. So you do need to hit pause to type those in, and you should. We've seen this in other sections. When we have this kind of the opposite way, like I say, when we're time traveling, figuring out what we need 20 years from now. I'm going to do a little bit of algebra. So that means if the present value is worth $120,000, maybe I won that in a lottery or something, I could set up this ordinary annuity and I would get $4,291.10 semi-annually, so every 6 months. That's not too bad. All right, example 3 is going to work like these guys. So I want you to hit pause and give this one a shot. Even if you haven't been hitting pause to check the calculator, definitely hit pause now to make sure you can set up and solve this guy. All right, this one worked like example 2. We wanted to know what our monthly payments were going to be, so we wanted to know R. Now, I told you this one was going to work like the other guys, and that's why I need you to remember when we're talking about these mortgages, these home equity loans and stuff like that, that we are going to be using this formula. Sometimes that's confusing at the beginning. That's where we add this in the notes to make sure that you know that you're supposed to do it. So that's why I said it was going to be like them so that you would know. So be on the lookout for this problem in my math lab and know to use this formula. All right. Ooh, there are lots of decimals there. Almost done with them though. So I type both of those in separately. Then I got 1 decimal with R. And then try to solve for R. I'm going to get R equals $244.30. So if I wanted to be able to have that $25,000, or I'm taking out that $25,000 mortgage, then the monthly payment would be $244.30.